All right, so today we're going to do a time series overview, a really quick recap of what we've already talked about, and then some potential extensions or different ways to look at time series data. Before I get started, I want to highlight that these topic deep dives that we've been going on, all these documents that I've been going through, these are actually linked on the homeroom. So this is our homeroom, which is linked at the top of our Slack channel. And you can see here that this is the schedule for all the study groups coming up. So for the last couple, we had like an NLP and a clustering overview. The docs are actually linked over here. So if you ever wanted to go back and look at those notes, a bunch of resources are linked on here. So that is there for you. Quick announcement before I continue. Monday's study group, I will not be holding because I will be on an airplane, but Joelle, another really awesome instructor, will be conducting office hours. And Joelle Joelle was also a former student, so they have, I think, we'll have good things to talk about with regards to capstones. All right, let's talk about time series. Cool. So just as an overall recap, and like reframing our minds to think about time series data. When we were doing time series, what was in the curriculum, where it was mostly the ARIMA-like models, which is any model that was linear. First of all, our ARIMA models were linear. The ARIMA components were the P, D, and Q, which stood for like the differencing was the D part, number of moving average terms, and autoregressive terms. So that was a majority of what was in the main part of our curriculum. With that, we also talked a little bit about decomposition. And we talked about it in several ways. One, decomposing seasonal trends. I don't think I said this explicitly during any of our study groups, but why seasonal decomposition works is just, let's say you do the seasonal decomposition, and then you see that, I don't know, let's say we're doing housing prices, and then every May, the price goes up 10% over its average. Every November, it dips 10% below its average. With that kind of seasonality, that's something that the model remembers, and then it's kind of additive. So what that means is, if I have my PDQ terms all laid out, that seasonal component is added onto the prediction from PDQ, if that makes sense. But that's pretty much what decomposition is all about. Also, a big part of what we talked about was stationarity. Stationary is important because ARIMA-like models work much better in stationary data. So we talked about differencing, which is the main one. Stationarity. Differencing is the main one, which is basically with like a, what do you call that? A time lag of however many. You're just going to take that change in price if we're doing price. And then that usually tends to make things a little bit more stationary. Differencing is good because differencing is something that is built into a lot of models, which is why I prefer it. So you wouldn't have to reverse transform it when you get your predictions. So differencing is preferred because it is part of the model. As part of the model of the, no need to reverse transform if we're using built-in models from stats models. Other methods of stationarity, of achieving stationarity, include log transforms, root transforms. However, the downside is these you will be required to reverse transform. So whatever your model outputs would be a logged version of price or a root transform of the price. So you would just have to reverse that to get your actual predictions. Models, outputs. Cool. So those are the main parts with time series that we talked about. What I wanted to focus a little bit more on are some of the things for you guys that are doing time series projects, some of the things that you can incorporate, or different ways of thinking about your data. So one thing before we get into it, the difference between predicting and forecasting. In the context of time series, this is something that is honestly in different things that you read can be quite ambiguous. But I personally like to make the distinction between predicting and forecasting just because it eliminates a lot of confusion. So for time series models, the difference between predicting and forecasting is when you're making predictions, predictions are basically the data that you use to fit your model, right? You can sort of think of it as a linear regression. I like to think of it with the under the context of a linear regression. You have all your data points, and then you draw your straight line through it. The predictions are where the points would correspond on that straight line. Let me actually just draw it super quick. So let's just say in a linear regression, we have a bunch of points over here. And if we draw our prediction line through, let me just make it a different color. So we have our prediction line here. Each of these X's represents actual data, but then the predictions would be the corresponding Y value for each data point. So for example, let's use a different color here. For this X over here, the prediction would be here versus, the actual X value, which is down there. So the prediction is a little higher than the actual value. So this is a prediction, and the prediction is on the training data. So in a similar vein, when you're making a prediction using a time series model, especially with the stats models, and I think the stats model syntax follows this as well. If you're doing a dot predict, the dot predict would be on data that you're training. And then when you're doing dot forecast, that would be looking forward. So forecast is specifically after the last day of your training data. Forecasting would be looking into the future, whereas predicting would be looking at, what would the corresponding straight line points be on the model, on the data, on the model that was fit on the data. So just to quickly summarize, dot predict is used on.
Sorry, could I ask? I think in the last real estate one, I used predict for future values. How is predicting future values different than forecasting?
I would go back and double check because dot predict
like it was outside my sample. So.
Oh, okay. So if you're doing it on the test set, and I think if you give dot predict on the test set, you have to give it some X values first. Is that correct? You would have to give it like your X test to do dot predict. Is that correct?
I'm not remembering. I just know I did dot predict for the last one, and it was for predicting future values. So.
Okay, I have to double check, but I think if you're doing dot predict for future values, it means that you're also giving it your test data points. So it still has those points. It's taking those points into consideration. Whereas when you're doing a dot forecast, if you remember the syntax for that dot forecast, you would forecast like a certain number, and that would be like looking into the future without any context of like, okay, these are the actual values. Whereas for dot predict, I think you give it some like X values. I think that's the difference. I would have to double check, but yeah, usually if you're doing dot predict, it's usually on like data that you have. But yeah, that's a good clarification. It's used for looking ahead past data that you have. Any other questions about this? Because I'm going to move on to talk about like additional things with time series data, that you can do with time series data. All right. So the ARIMA-like models, one thing that is good about it is that it's very, very interpretable because it is linear. So the coefficients will actually tell you the relationship between a time series and itself, like one lag time back, or even if you include exogenous variables, which I'll talk about more in a little bit, it will show you some linear relationship between the time series itself and exogenous variables, which can be very helpful in like deciphering relationships, especially if you're doing some sort of inferential model. However, there's a lot of nonlinear models that exist that usually provide a higher predictive power. The one that we talked about in the appendix is Facebook Profit. Facebook Profit, kind of similar to the ARIMA models. I actually, as I mentioned before, I haven't looked into exactly how it's done, but it uses a little bit of self-learning, but also uses the similar parameters of PDQ to make predictions. Everything is built in, very easy to use, so there's Facebook Profit there. One other thing that a few of you are actually trying to do for these capstones is looking into neural networks. Specifically for making forecasts, you will want to use a recurrent neural network. And there are different kinds of recurrent neural networks. RNNs are kind of like the umbrella term, and there are many different kinds of RNNs. But basically, the whole idea of RNNs is you are learning over time. So the order of your data matters. And in a lot of instances, that is, what it is, because like, let's say you're predicting stock price. It is likely that the price over the past 10 days and the order of, how the price has changed over the past 10 days, it matters. So yeah, RNNs are that kind of data. And to contrast, the other kinds of neural networks that we were looking at were like just the regular dense neural networks, convolutional neural networks. Those are all more of like classification versus forecasting. So with the classification for our data in regular neural networks, the order of our data points doesn't matter. In RNNs, it does matter. So the order of our training data matters for RNNs. I will admit that I don't know too much about what the specific difference is for GRUs, but I think that's a little bit in the appendix. I've had some experience with LSTMs only. So why LSTMs are a more powerful version of a regular RNN is LSTMs stand for long short-term memory. So LSTMs, long short-term memory. It's really, really useful for us because LSTMs sort of learn what information in the past was relevant. So I think when we were talking about like the Mod 4 project, there was this exponential decay that someone brought up when we were talking about. And the whole idea of exponential decay is that as time goes forward, points in the past will be less and less relevant, which is true in most cases. But sometimes you want to remember certain things. Like, for example, things like seasonality. We want to remember that every 12 months, there's going to be like a sharp rise in price, for example. And an LSTM is able to kind of remember that and just like learn patterns like that. So the whole thing about LSTM is it kind of learns how far back to remember certain patterns. So therefore, if you can argue that like, all right, if let's say we see a pattern that goes up, down, and up again, or actually let's make it a little bit more complicated. Let's go up, down, again. If it sees an up, down, up, it will sort of remember that first sequence and then be like, all right, yeah, because we've seen that up, down pattern a few times, after up, down, out, we're gonna go down. That's like a very, very simplistic example, but that's kind of how an LSTM works and how that's slightly different from RNNs. RNNs sort of consider the past with that like exponential decay being fairly constant. So yeah, I will say the math that goes behind LSTM is pretty complicated, and even looking at the structure of a neural network of an LSTM layer can get pretty dense. But yeah, that's in short how an LSTM is a little bit more powerful than just a vanilla RNN. So to recap, LSTMs are useful because it learns what to remember. Cool. I know a couple of you are using LSTMs, but any questions about LSTMs or dealing with LSTMs? I will also say the hardest part for setting up an LSTM is not so much like building the neural network. One part about it, and I don't know for those of you who have tried, that I found very difficult to figure out is the input shape for your data that goes into an LSTM. So just watch out for the LSTM input shape. If you run into any issues with that, let me know. I've debugged only a couple in my last couple of years doing this, but I have like a ton of examples to go off of. So if anyone has any issues with LSTMs, let me know. All right. The one more powerful thing I think that, well, I guess it's not unique to LSTMs, but I think something that is pretty neat with LSTMs is that it considers exogenous variables pretty well as well. It treats exogenous variables slightly differently from how it treats, well, kind of different to like how Saramax treats them. Let's go and talk about exogenous variables now. So with our ARIMA-like models, we have Saramax. For ARIMA-like models, we have Saramax, or basically the X part is what we're focusing on here. X stands for exogenous, so the X is what allows you to consider exogenous variables. And in Saramax, it's just treated as another feature. Each exogenous variable is treated as its own feature. One other thing to consider is I believe, okay, I need to double check on this. I'm going to italicize just in case, and I'll double check on it. But I think any exogenous variable will have to be different at the same, to the same degree as the time series. But I'm going to double check. Check if exogenous variables need to be different to the same degree. I'll double check on this and I'll like edit this if it's right or wrong. So in Saramax, if you were to run a Saramax model and you get that model output, you'll see for each exogenous variable, it'll have a corresponding coefficient, and that will just be the relationship between exogenous variable and the time series itself. So actually very similar to the output of a linear equation, of a linear regression. So for LSTMs, and actually similar for Facebook profit, exogenous variables are kind of treated just like, you know, any other X variable. So you don't have to really think about feature engineering your exogenous variables as much. Exogenous variables are treated just like other features in our regression or classification models. Cool. Questions on exogenous variables, because this is kind of like a segue to what I would next wanted to talk about. All right, something that I wanted to bring up is when you have a combination of a time series and exogenous variables, you have the capability of thinking about your time series data non-chronologically. And a way to think about this is set it up like our classification / regression models. So as an example, let's say we're trying to predict housing prices. To predict housing prices using past price data and features of a house. So this kind of combines our mod 2 project and our mod 4 project, because in our mod 4 project, we only had, you know, past zip code data, and in our mod 2 project, we just had features of a house. And I think it is worth mentioning that, like, yeah, if you're trying to decipher or predict the price of a house, both these things would be important. So to do this, one way to think about it is like a regression problem. And I think you might consider taking away time as a constraint. So one way to go about it is taking away the constraint of time. And so that means to not use time series models. So just really quick, how would that data frame look? So just as an example, all right, insert table. All right, let's put this down here. so that's all together. So first here we would have our price. And then let's say we have number of bedrooms, number of bathrooms, maybe square foot, and then so on and so forth. And then these will be the corresponding numbers. Another way that you can look at this is treat this as your Y variable and treat this as your X variable. So with this, you can actually just turn this into a regular regression problem. We've talked about linear regression in depth back in mod 2, but I think some of you know that there are a bunch of other regressions that you can use as well. There's like the decision tree regressor, there are random forest regressors, even KNN as a regressor. So there are a bunch of other models that you can use in this scenario, because doing this and by setting up your data like this, you take away the limitation of time series models. Let's just say that, you know, maybe you don't have data for every single day. If you don't have data for every single day, time series models might be a limitation. I mean, yeah, you're limited in the way that you cannot use time series models as effectively. Therefore, turning to something like this is a good alternative. Also, if, you know, let's say you want to predict something like years into the future and you don't have that data in between, a model like this also overcomes that limitation. So yeah, I don't expect everyone who's doing a time series project to, you know, redo their modeling this way, but I do think it is important to recognize that you can rethink using your data and just using a whole different set of models in making your predictions. Of course, with your data like this, you are not considering, you won't be considering the order of, you know, your time periods. However, that can be taken into account when you have dummy variables. So one way to reintroduce your time, especially if you have seasons, especially if you have seasonality, using dummy variables. So for example, let's say you see like a dip every November. You could have a dummy variable for, is this November or not? And then your model will learn that whenever you have like a November, the price is usually lower, stuff like that. But I do think this is something pretty important because in some scenarios, especially when you get to interviews, they want to see your creativity with your ability to take data and, you know, employ it in different ways. And I think this is one of the more common ways that you can use time series data, not using time series models. But yeah, I spoke a lot faster than I thought. I think I have to start speaking a little slower. But that's kind of like the main thing that I wanted to take out of this, and also to like summarize all the time series stuff that we've talked about. Does anyone have any like time series thoughts or questions that maybe you've come across while doing this project, or maybe just thoughts that you have going forward? Cool. All right, then. Well, honestly, this is kind of all I planned to talk about. I'm happy to take any other capstone questions if anyone has anything. I can stop this recording here. All right, stop the recording. I will put this, I'll put this doc on the homeroom. But yeah, we have about half an hour to go. Does anyone have any capstone questions? Well, sweet. Well, I hope you all are having a good Thursday so far, a good week so far. Oh, I hear someone. Hey, Kishore.
Just yeah, in the office still. So one question I had, I mean, I just logged in, so I mean, I could not go through the entire thing. But then today I had my career prep call, right, with Victoria, and she sent me a link which was related to some preparing resume, right?
Yes.
And I remember seeing it on Learn, but then like not in the Canvas.
Okay.
Career preparation. So, and then when I click it, it just goes to my very old link on Learn. where I had registered myself with the same.
Got it.
Yeah. So I don't know where the resume builders are on there.
Okay, let me show you all this. So you actually won't have this. This is actually like my old, like from when I was a student, this is what the career course was. Now it's different. Now it's actually on another platform. So if you click up the career prep on the top side here, and I think it'll bring you to this one here. This is where you will go through your career stuff. And in building your resume, there's no, I think that your career coach will send you a template that you can just edit for your own, but there's no like automatic like resume builder.
No,
You
so
just have-
this page I'm getting onto from the link that she has sent.
Okay.
I'm getting onto this page, but then I'm getting only the top part. It says like start your job search.
Oh, like just like only this part?
Yeah, I'm not getting the other parts at all. So I was wondering where the resume builders or the other things are.
Oh, like you're not getting any of these?
Yeah.
Oh, interesting. I'm not sure because I actually don't have much to do with like anything on this platform. But if you can send me some screenshots when you have time,
Yeah,
I can find out for you.
perfect. So that sounds great. I can do that.
Cool. Also, for resumes, and I actually spent a good amount of time like looking at well, not now, but I used to spend a lot of time looking at student resumes and interviewing people for Flatiron School. So I'm more than happy to look over your resumes as well. Especially there will be a section that has you like summarize some of your projects. Probably next week's study group. And as I mentioned, Monday I will be out, but Joelle will come and conduct a study group. So please come and ask questions. But on Thursday's study group, I will talk a little bit about resumes since you all are getting to that stage. And then I'll maybe talk a little bit about like preparing your GitHub as well.
When are you traveling? You said.
Yeah, I'm flying on Sunday.
Okay.
Yeah, and so with an 18-hour flight, I miss Monday as well. And also with like a 12-hour time difference, I'm not looking forward. I don't think I can like give a study group.
No, that's fine because I'm in constant touch with my Indian people, right? So we have the time, so almost the same time difference, but now it's 10.5 hours.
Yeah.
So just 1.5 hour difference. But yeah, so the next we are going to see you on Thursday.
Yes, you will see me on Thursday, sorry.
Yeah. Perfect.
So yeah, feel free to send over any like resume stuff that you all have. I'm more than happy to look over and give my comments.
Sure, we'll do that.
Awesome. Well, does anyone else have anything? Cool. Well, in that case, I will see you all next week. With regards to one-on-ones, I've already let you all know if I need to adjust our one-on-ones. So I think we're all good to go.
Yeah.
All right. Well, have a good rest of your evening, everybody. Bye.
Bye-bye.